morning, and welcome to this session about the life after C++. I'm very glad you're here, and I will be with you for the next 40 to 50 minutes. And my name is Michele Costantino SOCCIO. I work for Amadeus. Amadeus is the company that does everything about travel. We make travel work. So if you took a flight to come here, there are very high chances that we handle your ticket, your reservation, and even your boarding. This one is the programming languages track, but my apologies, it will not be very much about programming languages or languages. Is my accent okay? You can understand me? Okay. If I switch to Italian, it will not be better. So it will not be about programming languages, it would be about tools, because I work as a principal engineer, but actually I am a carpenter. The most attentive of you will notice that this person is not me, but we have something in common. Because I also use tools to build stuff. And what I want to do, okay, is I want to understand how the tools will evolve and how that will impact my way of working. Okay? Quick show of hands. Who could recognize both languages? Okay, for the others, I will give you a little hint. One is an old language that has an obsolete design that has been holding the industry back for years. And the other one is COBOL. Okay, so is C++ under attack? So we have seen a few government agencies that are asking, oh, please stop using memory unsafe languages, and they explicitly mention C and C++. And they started with the NSA. Then there was another very exhaustive paper by several agencies, including the NCSC UK. I don't know if you know about it. And then, just to sign this one, the White House also did a sum up of these reports, recommending we need to find a way to move away from a memory unsafe languages. But Michele, come on, these are bureaucrats. We cannot listen to bureaucrats. We need to listen to someone that know about technology. Speaking of languages, it's time to halt starting any new project in C and C++. For the sake of security and reliability, the industry should declare those languages as deprecated. Who is this guy? It's the CTO of Microsoft Azure. Okay, I blurred that word because it may be offensive for some C++ developers. Michele, this guy wants to sell some .NET stuff, some Azure subscription. Let's talk with someone that really knows C++. C++ is now fundamentally broken. Nikolai Yusuttis, a C++ trainer, author of several C++ books, member of C++ committee for over 20 years. And the one thing that Nikolai Yusuttis is saying is also that in 10 years, C++ will be 50 years old. And okay, we could take a new programming language, but according to him, in his opinion, there is no new programming language that could actually replace C++. I am sorry, but now I need to use that offensive word, okay? So I need to use the R word. Let's talk about Rust. What is the first thing that comes to your mind when you think about Rust?
Borrow check.
The borrow check. This is a picture of the borrow checker and me, okay? It's fighting the borrow checker is a typical thing. Oh, Rust, you spend time fighting the borrow checker. But when I try to understand why this hype on Rust, and by the way, there was a nice talk yesterday by Matt C, last talk of the conference. about Rust 101. And when I checked about when I had a look at Rust, there were a lot of other things that were interesting. For example, the multiple inheritance. C++ started with was one of the first mainstream languages to implement object-oriented. He took it from Simula, and which is basically a merge of Simula and C. And he started with multiple inheritance. And Java is the very first successor language of C++. Let's take whatever C++ is doing, remove everything that doesn't make sense, and we make a new language. So Java said, multiple inheritance doesn't make sense, let's go single inheritance. Rust has no inheritance. They use traits. Another thing that is interesting, also the approach to generic programming. Alexander Stepanov introduced, he basically introduced the generic programming to the mainstream. He's one of the mind behind generic programming. Introduced the templates in the STL, in the standard library, in the standard template library in C++, but they are hard to use sometimes, so now they are doing something that is a concept in which you have a little bit more powerful, but they're not getting so much developed yet. I think concepts are C++ 20 or 23, don't remember. In Rust, you have again traits. And there are a lot of things that are very nice in Rust. You have the memory save. I really love cargo because you have one tool to handle dependencies and to build. And we have a tool that has this approach, dependency and build at the same time in my company. It's a proprietary tool, and it's something that we deeply miss in C++. We have CMake that is only for building. And then we have several attempts with the package. We have Conan for the package management. And those things, they are usually very well separated and it's very complex. Just think all the time, oh, I have this nice library. It is headers only. Because everybody knows that installing a dependency is very cumbersome. So you have very clear error messages, no more exceptions, modern way of handling errors, a very nice pattern matching, no inheritance, because remember, inheritance is the base class of evil, and you have a very strong typing. So talk is cheap, show us the code. Duplicate. Can you see the screen? So what I want to do, I want to write first in C++, I want to take all the numbers in a vector, okay, sum them together. It's a very easy one, okay? I have some notes here that I print very, very small. So I have vector double, for example, V, and it would be 1.1, 2.2, 3.3, 4.4. And how much is the sum? Come on, 11. Perfect. Okay, so let's do it in a very silly way. I have a counter, I have a double sum, okay, and while n is v.size, okay. What I do, sum plus equal v.n and n plus equal 1, okay? I write like this because, for example, in Swift, they remove the plus plus and the minus minus. You must use this way. So people don't argue anymore. Oh, you should put plus plus 1, plus plus n, or n plus plus. Okay? Then standard cout sum standard and line. Okay, very well. Now, if I go here and I will remove all the things that I already. Okay, if I compile the accumulate.cpp, Sum was not declared. What do you mean, sum was not declared? Oh, okay. Yeah. I mean, expected before double, okay? You will see some error in Rust there, much better. Okay, we compiled. So, 11. Very good. You know math. But, I mean, we cannot do with a while. We should use a standard accumulate. Come on. We are good programmers. Standard accumulate, v.begin, v.end. And standard accumulate needs something to start from, okay? So we just do this one. So this 0, we put it here. Double sum, I put it here. This one, we don't need it anymore, okay. Should be okay. Let's try to compile. Expect 4 arguments, 3 provided. What is wrong with this? Is this one. When you work with Scala, in Scala, you don't have to put the parentheses if you don't have anything. So a function looks like a variable. It's quite funny. So G++. Okay, let's run. We said it is 11, right? No, it's 10. Let's try to do the same thing in Rust, okay? We'll try to use a very similar way of writing this. Okay? So we have a let v. Okay, I don't want to use this sum. I want to use something that is exactly the accumulate because I want to show you something. Okay, is a vec of 1.1, 2.2, 3.3, 4.4, which math should be the same. It's still 11. Okay, then I will have let sum. I want to say that is f64. I want to iterate over all those. Instead of doing the sum, I will write a longer way because I want to show you something. Fold, okay, starting point, I'll fill it later. And then you have a lambda. That is, looks like this. This one should be, this one to be more correct, yes. And the starting point is the same as C++. So it will be 0. And then, come on, print. Perfect. Let's compile. Let's compile this one. Rust c accumulate.rust. You see, it's saying what is the error? We have a 0 here, but it's expecting a float. Okay, this argument influences the return type of fold, and this is what's happening in C++. So here, if we put .0 and recompile, accumulate 11. But Michele, in C++ you didn't put any warning. We do have a warning, but it's not about that. Sorry, I forgot to remove this. We have absolutely no warning. Okay? So this is something I really love about Rust. Now, let's go back to the slides. Extend. I need to go out and reshare again. But is Rust actually used? Come on, it seems nice, but is anybody using it? Let's first have a look at the timeline. In this timeline, you have 2 very interesting things. First thing is that COBOL is still updated. And the second interesting thing is that between COBOL and C++, there is less time than between C++ and Rust. Okay? So, is Rust used? Rust was originally a pet project, but then was sponsored by Mozilla, and they used to rewrite some part of Firefox. And I checked the other day, and if we remove JavaScript, HTML, we only concentrate on system programming languages, Rust has about 1/5 of the total code base of Firefox. And if we look at the market share of Firefox, it has been an enormous success. See, Michele, Chrome, C++, much better. And Google also wants to use Rust in Chrome. And they also want to use Rust in Android. Okay? And do you remember this guy? This guy from Microsoft, and the word that I blurred was Rust, of course. They actually doubled down, not only new projects, they rewrote some part of the Windows kernel in Rust. And if you have a Windows 11 laptop, I would like to see if this part made it to the stable release. And then they rewrote other parts of Windows in Rust. And even Adobe is producing software in Rust. Okay? And they are doing more than that. They have one library that they use for concurrency, and they've experimentally rewritten it in safe Rust. Okay? So there is no unsafe. They have the guarantee that is memory safety. And it was slower. But according to Sean Parent, the senior principal scientist at Adobe, any talk that you find on YouTube about Sean Parent, go and look and watch it. So they are still looking into moving the critical components into Rust. And if they can make this implementation just a few percent, a little bit slower than Rust instead of 15%, they will swap it. They will use the Rust implementation instead of the C++. Okay? Very good. The interest of this one, who knew about Hylo? I got you. The interest of Adobe is also in a new language, is a research language, was called Val before, and has been renamed into Hylo. Okay, it's a research. And it wants to be fast by definition, safe by default, all those things. It wants to be friendlier than Rust, and want to have a simple generic programming. Okay, Rust is also already quite good, and wants to be fully interoperable with C++. Okay, in Rust you don't have that. You need to write some bindings. So it started with a scientific paper, just to have some names. Dimi Racordon is the person that is writing on the compiler. Dave Abrams, who know Dave Abrams? Is the founder of Boost. Okay, the Boost libraries, they are there because of Dave Abrams. And he's also the person that is behind the Swift standard library when he was at Apple. And now he's at Adobe. And so the whole thing is about mutable value semantic. So what Val wants to achieve, they want to achieve local reasoning. So when you look at a piece of code, you should be able to fully understand it without considering any of the rest of the system. And to achieve that, they want to use mutable value semantic. So value semantic, we know, no more references, okay? Every time you assign something is a copy, and then you hope for the compiler to optimize it away. And thanks to this, you're always sure that nobody will ever take ownership. Will ever be able to write while you are reading that value, okay? Is behind the scene is very similar to what the borrow checker does. And mutable means that, okay, very good, we want to copy everything, but our CPU, they don't work like that. Our CPU, they actually change the value that are already in memory, because the compilers, we know that the compiler will never be able to optimize 100% of the copies. Okay? Do you know which language already has mutable value semantic? It's not COBOL. It's not Python. Okay? Because in Python, when you do this assignment, it's not making a copy. When I modify v2, I'm also modifying v1. One language that supports mutable value semantic is C++. When you do this assignment, you are making a copy, so whatever you do to v2 is not reflected in v1. But Hylo does not derive from C++, Hylo derives from Swift. It's written in Swift. And the thing started thinking, can we make Swift completely mutable value semantic? Swift has mutable value semantic, but it does not implement, is not pure, it's not 100%. For example, for concurrency, they cannot use it. And also they want to do, can we do the zero overhead principle? Like in C++. In C++, we don't want to pay for what we don't use, okay? Instead, in Swift, basically they achieve that, but every time you try to write some value, they will, okay, I will make a copy so that you can write your own. Hylo wants the compiler to reason about the logic that you have behind your code, a little bit like the borrow checker, so that it can tell you, okay, here you cannot do this, here you must do an explicit copy of the value if you want to modify on your side without influencing the others. And they both want to be interoperable with C++. Hylo is a research program. There is nothing about that. We will see that Swift has something about working with C++. Okay, you want to see some Hylo code? Huh? I think I'm the first person that shows some Hylo code in live. I need to switch to... What the hell is my mouse here? To duplicate, okay. I have this thing, okay. So here I basically have a flight as a two-member string and passenger, and this public member-wise in it is just a way to say generate me a default constructor. And this conformance is basically a trait, and is de-initializable. It means I have a deconstructor because I want to print something when we shut down a type, when the type goes out of scope and gets destructed. The print is look a little bit strange because it's a very early stage and the print does not have all the things. It could only print something and you can add a terminator, like usually it's the new line, and I use that one to try to compact a little bit. So this one, print flight, is just to have some pretty print. And this is the main. So I'm creating a flight that is going to London. I print it and I get the packs. This packs here, okay, this value here is not a copy of passenger, is observing passengers, is an observer, okay? This flight.passenger is still the owner, is the value, this one is an observer. I could print it. After that, I can increase the number of passengers, okay? And it will print the result. So let's see. Open a terminal, alias compiler, and this one is in examples, Devox UK, and then Hylo C. I don't have anything in memory. Hylo C, local bindings.hylo. Alias, I just did it. AC. Local binding.hylo. Takes a long time to compile. Okay, so what we expected. Okay, last line is the. Let me put it a little bit higher so it is easier to see. Like this. Is it better? And we turn off this part, okay? So this one is so what happens if I use, instead of let, I use a var? So is not, I want to, this one, I want to make it mutable. It should complain, hopefully. Yeah, because at this moment, okay, you want it to be mutable, so you are not an observer. You have consumed in the term of Hylo, this one, is like a move, but a move you're thinking in reference semantic. You consume in value semantic. Okay? And same if I swap these two lines. If I swap these two lines, what happens? Here. Yeah. Illegal mutable access. Because, you have an observer that is used after the passenger has been modified. So the compiler cannot promise you the local reasoning. You are taking this piece of code, I'm printing it, but you need to know what's happening before. Okay? So this is about Hylo. Yeah.
Can I ask a question?
Yeah, please.
So let's say you wanted to take a copy of the passenger, then you increment it, and then later on you wanted to remember what it was before increment. How would you do that?
You need to make a copy, so it would be like a let packs, and then you do a dot copy. In Hylo, all the copies must be explicit. Okay? If you do like this, then, if you put var in this case, this one will be okay. I'm not sure that copy is implemented for int. There are a lot of things that are really is in a research phase. They have a very nice Slack chat, and I talked myself to Dimi to make some of the examples work. Okay. I hope he will not be angry at me if I misspoke about Hylo. Let's go back to the presentation. So, Hylo derived from Swift. Is Swift a successor language for C++? So, Swift is the Apple language. If you want to write a little application or a big application for Mac or for iPhone, you probably will use Swift. It is open source. It is open source since version 2.1. It has become also multi-platform. You can make it run on Linux. It is safe. It's not only used on iPhone because they have implemented interoperability with C++ to make it work in FoundationDB. Who knows about FoundationDB? Oh, good. So FoundationDB is a distributed key value database that is used to build other databases. Okay? Do you know Snowflake? Yes, Snowflake use FoundationDB. And iCloud use FoundationDB. So, how do they work? Do we need bindings? No, we don't need bindings. Do you want to see how it works in Swift? Okay, it's the only code I ever wrote in Swift. Let's go back. Here, I don't need this window anymore. I should have this one is Rust. I don't need it anymore. DevOps Swift code. So, I have a flight class, okay? That is flight number, from, to, give me the flight number, how many seats are left, and when you do a cell, you decrease the number of seats available. This is what Amadeus does in few lines. But we made it several 100 million lines of code. Okay? So this one is the implementation. It's a typical, very simple C++. It's just a class. So the first thing you need to do if you want to use it from a Swift, oops. Okay. If you want to use it from a Swift file, the only thing you actually need to do, you need to instrument a CMake. But you have problems with CMake also if you only use C++. So, but the most important thing that you need is you need to tell in this module, you need to create a Swift module, okay, in which you just say that this module will use fly.h. That is this file, okay? That's it. No bindings. Swift compiler will ask LLVM to do all the connection between the C++ and the Swift one. So then in Swift, what you do, you import that module we just declared, okay? And then you can have var flight1. Okay, this one is a flight, and it is, I have it written here. It is the BA3279, and is going from London City to Florence. Okay, and I can do flight1 dot pretty print, and then I can create another one, var flight2, flight BA 8475 and CE. Okay, flight 2.pretty print, and let's say that on flight 1 I sell 50 tickets, and on flight 2 I sell, to use the numbers before, 11. Okay, flight 1 dot pretty print, flight 2 dot pretty print, and then to compile it, remove the build that I used before, CMake, and you need to use the generator Ninja. You can use make, you must use Ninja. So, yeah. Now, if you do make, sorry, I just said it, and airport. So we just used C++ from Swift with just, what is it? Writing 3 lines of code. That could become 1. Look. Okay? Do you have any question about it?
When you do this, is the IDE able to then autocomplete from the header file?
It is able to autocomplete. I didn't have time to set up VS Code to do it. On Xcode, it works out of the box. Okay? But this is a Windows machine. I do have a Mac. I tried on Xcode. It works out of the box. There are ways to set up the what is that thing called? Like the Clang D. I don't remember anymore. Anyway, to set up the a language database with all the calls, so that the IDE will be able to autocomplete. But with GitHub Copilot and also with Codeum, they are able to guess even if you don't have autocomplete. So the autocomplete actually gets less and less important. But they do hallucinate, of course. Very well. So finish the demo. I do have other demos, just that I don't have much time. And slideshow, start slideshow. What's next? Guess. You know, Carbon. Carbon is an experiment that wants to make wants to be the true successor of C++. They want to make seamless transition, almost similar transition. Okay, they want to be a viable way to replacing for at least some users, not for everybody, but for at least some users, the entire development process. Please. Yes, it's the Google project, but there are also people working on it that are not from Google, but it's mainly a Google project, yes. If you want to know more about it, look about Chandler Carruth, okay? And all his talks about lately about carbon. And there is extensive documentation, is very actively developed. So Carbon wants to be respective performance requirements of C++, wants to introduce breaking changes. In C++, we don't have breaking changes. We will break all the code that was written 30 years ago that somehow some people are still using. But they want to use a compiler made today for that code. They could use the compiler from 30 years ago. And thanks to the thing that the evolution could introduce breaking changes, they will first go with interoperability with C++. Then we have new versions of Carbon that will introduce more and more memory safety. But for that one, you may need to break backward compatibility. Okay? And they want to do full interoperability with C++ and also provide tools to migrate from C++ to Carbon. They also use the same trick as Swift, go down to LLVM and make LLVM handle the connection. But in general, let's imagine that you have another compiler that does not use LLVM. What they do is that imagine that you have a header files that is a class cat and has a method meow and a certain number of lives, okay? And all this, you know the old saying, an artist copy, a great artist steal? All these examples, I copied them. So these header files will be synthesized. There will be a module, a C++ module that will be generated. So starting with C++ 10, 20, basically this call cat meow will, this function call cat meow will call the function member meow here, okay? From this one, they will synthesize a Carbon package. So it will be CPP. It's called a package called the CPP. That will have a class cat. And we'll have the function meow, okay? And there will be some magic to make also the members work, the variable members work. And then from Carbon, you can just use import CPP library. You give the header and use it as it was a normal thing. The aim is to have both. The aim is to have both interoperability in both directions. C++ should be able to call Carbon seamlessly, and the Carbon should be able to call C++ seamlessly. You should actually not be aware of what was the original language of the module that you're using. So it's very ambitious. When can we have it? It is an experiment. So next year we should have minimum viable products with complete C++ interoperability so that people could start experiment. Later, they will add memory safety and the language should be feature complete. So you can evaluate everything, and only if that evaluation is positive, if the experiment is a success, beyond 2027, we can have a production-ready version of the language. Is C++ doomed to stay if we need to wait so on? Again, Sean Parent is not going away anytime soon. Okay, Photoshop has 30 million lines of C++ code. Other companies, they have a similar size projects. Is not something that we can translate to another language. How about the successor languages? The strictly successor language, though they say, we will have full interoperability, they are a long shot for now. Swift has interoperability, but for example, doesn't support templates. And there are other things that don't support because they really made it to use in Foundation DB. There will be evolutions. but it may take time to have a complete interoperability, if ever we will have a complete interoperability. The replacement languages, okay, Rust, Zig, for example. I didn't talk about Zig, but Zig is also a very nice addition that we had recently. They can be used for new project, okay? And all those government agencies, they're saying new project should start in C, should not start in C and C++, should start in a memory safe language. It could be Python is a memory safe language, but of course you don't have the same performances. Mojo is quite an interesting thing. I don't know if you heard about Mojo. Yeah, you heard about.
It's now open source. So
Yeah, okay, they open source. I did.
they just announced it last month. It's on GitHub now.
Oh, okay, that's great. Mojo is basically they took Python. I don't know if it is it 100% compatible with Python, Mojo?
It's a superset of Python
Okay.
created by the inventor of LLVM.
Yeah, that one I know. So just to repeat for the recording, Mojo is a superset of Python. It was created by the creator of LLVM. Andrew Kelly, I think. Don't remember his name.
The Zig guy.
Huh?
The Zig guy.
It's Zig guy. Yeah, Andrew Kelly is the Zig guy. Yeah, you're right. Yeah. Andrew Kelly is the Zig guy. So, but I mean, those reports from government agencies, they're talking about you need to train people, you need to check your hire. I don't know what kids study nowadays in universities. I mean, it looks like I'm 20 years old, but I'm not. So you need to make a roadmap, okay, to move away from this one. You need to make sure that you reduce your exposure to memory safe, because memory safety is 70%. Okay, this is a number that comes from both Microsoft and Google. 70% of all vulnerabilities, they're about memory safety. Okay. So, how about those scary reports from government agencies? There will be some work to do. And you know, at the beginning, I told you that this talk was not about programming; it was about carpentry. And of course, that was a lie, because this talk is about farming. How do you milk a cow? Do you milk it like this? No, you cannot milk a cow like this. For hygienic reason, to milk a cow, you must use a milking machine that can be inspected. Okay? If you milk a cow in this way, you cannot sell your milk, you cannot sell the cheese you're making. You must use a machine if you want to sell your milk, if you want to sell the cheese you're making. Okay? And we are going in the same direction with system programming. Okay, we will need to have audits. We will need to demonstrate that we took all the necessary measures to reduce possible vulnerabilities. There will be a shifting left of responsibility. Now, when you install a software, we decline all responsibility in the case the software is used in improper ways. That one is shifting all left. Okay? There are also regulations in EU. I know that here in UK you don't care anymore. But there are regulations in both EU and in US, what we saw, that are shifting that responsibility left. So we need to be ready to be safer, whether it will be with C++ that is here to stay anyway, whether it will be with new languages. So I really had a good deal of fun preparing this talk. I talked with several interesting people, not as interesting as you, of course. And I really hope that this talk has sparked a little bit of curiosity in you, because being curious is the best way to be ready for change. Thank you so much. We have a few minutes if you want to ask anything. Also not related to this. Yeah.
about the other approach, like formal proof?
We have a mic.
So the current approach around safety is often around
Yeah.
borrow checkers and other tools like this. But the alternative is kind of like going to the C++ kind of school of thought and formally proving your code instead.
Yeah.
So why do you think there's not so much research going that way? Like Simon Peyton-Jones building Verse at Epic right now is kind of going in that way as well.
Yeah, there are two things about this. One thing is about auditing. Okay, if I use, for example, an address sanitizer, or if I use a static analyzer, can I prove that to make a certain version of my software, I didn't bypass it? Okay, in Rust you cannot bypass it. There is no option to say, oh, forget about this thing. You can use unsafe, but then if you go to inspect the code, you have this unsafe that is very clear. In C++, you don't have that.
So I mean C++, this is the case of, so are you familiar with C++?
No, I don't
So
know.
it's a compiler. So C++ is a
Yeah.
compiler target, effectively, which was originally used to do formal verification of language. So this goes beyond the way borrow checkers check to make sure you've not, handed off ownership of an object.
Yeah.
You clean it up afterwards. With this, you formally prove, so you mathematically
Okay.
can never go out of scope.
Yeah.
It's an alternative approach. Borrow checking effectively says we're going to check after the fact and make sure you just don't move memory, but you'll still leak, you can still race condition, you can still everything else.
Yeah.
Whereas formal verification says we can't even do that. My question is more about so this came from the kind of the Haskell school of thought, which is you can, if you go even further than where Haskell went, you can formally prove your language
Yeah.
in your code.
And there are, I think that there are also some experiments to do this kind of a formal proof in C++. There are some papers. I don't know what is their status, but I was reading about those in the past. And I know that there is at least one guy, that is Sean Baxter. Is writing on a compiler. It's called Circle. It is also a superset of C++, and he has implemented some of those concepts in C++. And I think just a few weeks ago, he also announced that okay, we have full memory safety in Circle, and we have he used the borrow checker. Okay.
I'm definitely going to have to look this one up.
Yeah, no, it's and it's funny because you know that tweet about from the CTO of Azure, okay, and Sean Baxter has a very strong answer to that one, but he did pass from words to fact. I would show you that in C++ we can have memory safety, yeah, but the borrow checker is just a way is a little bit less theoric, okay. It is a little bit more pragmatic way to prove that that thing is safe. And maybe it's not, I don't know if it is mathematically proven that the borrow check is 100% memory saved.
It is one of it's the other classic empirical versus kind of theoretical proof approach.
Yeah. In Hylo, that paper, they first proved theoretical that mutable value semantic can be done, and then they implemented it.
If you look at the language Verse, it's quite similar to that approach. So Verse is a prologue-ish language
Yeah.
designed for exactly this purpose.
But there are a lot of other experiments that I couldn't put in this talk. Any other question? 1 minute? Okay. Thank you so much.